Step back in front of your camera.
Yeah.
I'm not seeing your camera update. Are you?
I see myself. I see you. I see the widescreen shot.
Okay.
You're quite pixelated.
We're live? Oh, okay. All right. We are live and ready to go. Welcome to everybody joining us from the live stream. Patrick and I are doing a CCNA prep live from Cisco Live here in Melbourne. We'll get started here with our content momentarily, but we wanted to welcome you all coming back to CCNA prep. Patrick, how's Cisco Live been for you so far?
It's been fantastic. Meeting with customers and partners and learners, right? We're at the Learning and Certifications booth where we're talking about learning. We're talking about certifications, and well, we're talking about CCNA today. What's your highlight so far?
Oh, it's got to be having a chance to talk with people face to face, right? The digital experience, the community we have, all of those are really great. And the CCNA prep webinars have been fantastic. But there's just something about having a chance to be able to be in person, talk with somebody, compare notes, compare ideas of what's going on. That's always a highlight. But that said, we can't always have people in person. So we're excellent. So happy to bring you all in over the live stream for this special session, CCNA prep live from Cisco Live. And we're looking at our audience here. We've got people coming in from all over the place. Lots of representation from the US, which is fantastic. Though, Patrick, you're feeling a little sad.
I am sad. I am sad. There's no one from Canada. But for those of you who are joining us in person, if you want to scan the QR code, we'll be doing some Q&A through Slido. And then you can jump in and let us know where you're from. Well, we know where you are right now, but if you'd like to let us know where you're from originally, that'd be cool too. Fantastic. But yeah, we'll have some questions throughout the session today, so feel free to join.
Yeah, absolutely. We've actually had some questions come in from chat already, and there's a few here that have been interesting for me. So, Patrick, one of the questions came in. Joshua asked. He said, "Hey, while learning the CCNA, is it a requirement to have knowledge of coding in any programming language?" Great question.
Great question. Yes.
So what would you answer to Josh?
Listen, you are the expert on automation and programmability. Just keep if you have a look at the exam blueprint, we know that one of the domains in there is all about automation and programmability. Now, listen, we're not expecting you to be an expert in Python or any of those other programming languages, but some knowledge of, right? Just an understanding of how it can be used in networking specifically, I think is the key there.
Exactly. And one of the things we've talked a lot about around the CCNA or any certification is take the time to look at the blueprint, explore the tasks, specifically the verbs associated with a task. We do have a domain about automation programmability, but none of those verbs say write code or configure or apply or automate. It's explain and understand kind of the role that automation or AI might fit with network operations that are in there. So at the CCNA level, it's great to have skills on how to code, but it is not required for the certification.
And I think one of the other verbs we've seen recently appear in the blueprint is the verb interpret, which I think is a really interesting one. That means you might get a question where you see some code, any kind of code really, and you just ask, what's this code doing, right? And so I think that's another interesting verb too.
Exactly. Awesome. All right, well, with that in mind, bring in more questions. We're watching them. We've got our you'll see Rigo's not here in person with us today, but he is watching our chat and helping us make sure that we keep accurate with all your questions. So Rigo, we miss you down in Melbourne. We'll see you in Amsterdam, I think, but I think it's time to dive in, shall we?
We shall. I'm just having a look. Still no one from Canada. That's okay.
All right, that's fine.
Right. So, I mean, I think it's about a month ago, maybe a little bit more, we did an episode where we looked at just the foundations or the fundamentals of routing, looking at the routing table, admin distance metric. We focused primarily in that episode on static routes, and we had put together a lab allowing you to kind of explore how to configure static routes. And there were 3 parts to that lab. Part 1 was, the first bit here was just configuring traditional static routes, either with the next hop IP or the outbound interface or a combination of both. So we managed to get through that in that episode. And then part 2 was kind of cool. It was looking at how we can use static routes for redundancy, so floating static routes. And we looked at how the admin distance can be changed to pull that off. And we were having so much fun, we kind of ran out of time during that episode to look at part 3. And so we thought we would revisit part 3 here. And so I think we're going to pull up our first Slido question.
I've already activated
fantastic.
So it's out in the queue. Lovely. So if you're on the Slido, we've got a question out there all
about, yes, okay.
Different routers prefixes. So answer that while we go through
fantastic.
This
okay. So before we jump into the lab, I think it'd be a good idea just to kind of explain what I was trying to do here with the topology, and then have a look at how the routers are actually configured. So we have a bit of a hub and spoke topology. You can see router 1 at the top, router 2 in the middle, and 3, 4, 5 across the bottom. Obviously, all of these routers are connected together across some /30 networks. You can see 10, 1, 2, 10, 2, 1, 2, 10, 1. Sorry, let me try that again. 10, 1, 2 across the top, 10, 2, 3, 1 on the left, 10, 2, 4, and then 10, 2, 5. Those are just the connections between the routers. But then the other interesting thing that I did was created the same loopback interface across all the routers. I know this might look a bit odd. I did that on purpose because I was trying to actually simulate an interesting problem, basically, so that we could check what's actually going on. So that's the basic setup. Now, where things get a little bit even more interesting is that what I've done also is I've enabled 3 routing protocols in this environment. I have RIP version 2 running, I have OSPF running, and I have EIGRP running. Now, why did I do all that? Again, you wouldn't do this in a real life scenario.
Please don't do that in
Yeah,
real life.
please don't.
Absolutely.
What I needed to do is I just wanted to create some interesting entries in the routing table. I just wanted to be able to add some interesting stuff in the routing table. So I've enabled all of these routing protocols. And to be honest, the reason I want to do that is because in this episode, we were exploring everything that had to do with admin distance. So maybe just a quick reminder about default admin distance values. When an interface is directly connected on the router, that'll have an admin distance of 0. So maybe a quick question. What's the best value? A small admin, a lower value, or a higher value for the admin distance? Anyone want to try? Administrative distance.
Smaller.
Smaller the value. Thank you. Yeah.
Absolutely.
So directly connected network would be the best. Then a static route would be the next best one. Why would that have a value of 1, Hank?
Oh, it's a really good question. So the idea here is that the router's directly connected. That's obviously the best. The router can directly go into it. We've got dynamic routing protocols with these other ones that are in place, but static routes, they have just 1. It's the second best. And that's because the idea behind a static route is it means that a network engineer explicitly went in and configured this to be the route. And the idea from the router's perspective is if the network engineer, the network architect said, this is how I want to get there, we're going to disregard everything else and use that static route. And so keep that in mind, particularly as you're migrating from static to dynamic, is that those static routes will override anything you might be learning from a dynamic source.
For sure. And obviously the next 3 are the other routing protocols that I've enabled in the diagram or in the topology. So EIGRP has a default admin distance of 90, OSPF 110, and RIP 120. So keep that in mind. Let me now show you how it's actually configured. Again, we're not doing a deep dive in how to configure RIP or how to configure OSPF or how to configure EIGRP. The only reason I did this is just to create some interesting stuff to look at in the routing tables. I think the best way maybe to show you this would actually in the PDF. So bear with me here for a second. So just a quick reminder, those of you that are signed up for CCNA Prep, you can download the YAML file for CML. You can download a packet tracer version of that, but also you can download this PDF, which is the lab guide we had created for this particular episode. Okay, so here we go. I'm just scrolling up. Almost there, almost there. Okay, so this is the config on router 1 that you're seeing over here. So you can see that we've got EIGRP configured for the 10 network and the 200, 200, 200. That's that loopback interface. We got OSPF configured for the same thing, the 10 network and that loopback. We have RIP configured, again, for 10 and 200, 200, 200. And interestingly enough, I also added a static route on R1. And you'll see why in just a second as we start playing with this. R2 has EIGRP, OSPF, and RIP configured as well for the same networks. R3 has EIGRP, OSPF, and RIP configured again. R4, same thing, EIGRP, OSPF, and RIP, and R5 as well. So they're all configured with OSPF, RIP, EIGRP. R1 just had that extra little static route that I created as well. Is this making sense so far? Cool. Let me pull up the routing tables now. Let's just have a quick look at that. So I'm on R1 on the left here. If I do a show IP route, what are we looking at here?
Maybe
we've got obviously a connected.
Let's get like a command plus plus.
Yeah,
thank you. For those on the stream.
Let me do this here. I think I'm gonna have to do this. Zoom in here. Clip, clip. Yeah. How's that looking? Is that better?
Probably good. Yeah, that should be good.
Okay.
Awesome.
So what do we have here? We've got obviously the 10 network that we're directly connected to. We've got 3 EIGRP entries. So those are the networks that are connected between R2, R3, R2, R4, and R2, R5. It's fine. And those ones are being learned through EIGRP. I can see the value of 90 here in the letter D. Okay. And we know that EIGRP wins against OSPF, wins against RIP. So that's why we've got those. And we can see that we've got currently our loopback interface configured on the R1 router as well. I'll just have a quick look at R2 because that's the one in the middle, and it's probably the one that has the most interesting stuff to look at in terms of all of the networks. So Hank, I'm going to put you on the spot here.
Ooh, we always like that.
So there's some interesting things going on the R2 router. Let's just kind of focus on everything that's going on down here. So Hank, there's something strange going on. R2 is learning the 200.200.0/24 network, and it's learning it from 4 different neighbors.
Yep.
Using EIGRP, but also 200.200.200/32 through OSPF as well.
Exactly.
From those same neighbors. What's going on here?
Yeah, so what we're seeing here is that the reason we have 4 routes is that routing protocols and routers, if the metric is the same, and so we can see the EIGRP routes here all have 409,600 as the metric. And because they're all the same metric, the router can equally use them. It's equal cost load balancing for the routing side. And so that's why we have the 4 from EIGRP. We have the 4 from OSPF for the same reason. Once again, they all have a metric of 11. The metrics for each routing protocol are calculated differently. And we're not going to go into detail on that here, but that's why those are on that side. Now, the real question, I think what you were hitting at here is we've got 200.200.200/24, and then we have a /32 route for them as well. The reason we see that is kind of an intricacy in how OSPF works. Loopback interfaces within OSPF, and I think only OSPF, OSPF defaults to say, okay, even though it's a loopback, I don't care what the subnet mask is for that. I don't care what the configured network is. I'm just going to advertise it as a host route, a /32 route. I think that some of the reasons behind that is that a loopback interface is not an interface that goes to other hosts, right? A loopback interface only is one interface on the router. And so OSPF says, well, we're just going to hone in on whatever IP address the router is configured with. Now, there are ways within OSPF to tweak that. And it's something we sometimes do in classes when we're learning about OSPF is you can tell the router to treat the loopback interface like a point-to-point interface, in which case the actual configured subnet mask would be advertised instead of the /32. And that's a useful trick when you're studying OSPF and trying to manipulate what the routing tables look like.
And again, you wouldn't want to do this in real life. What I'm showing you here, I'm just trying to do something interesting to kind of look at and demonstrate. And also I want to break a few things and see what happens. Because as Hank was saying, and Hank, again, can you imagine if from R2, I was to type the command ping 200.200.200.200, where would the packets go?
Which route would be selected? Right? The routers are going to just kind of load balance across, typically, is that each packet would go from one route to the next route and to the next route. That's the value of equal cost load balancing, which would be interesting. R2, I expect, would get replies from each of the routers because they all have that IP address. But each reply would come from a different router.
It'd be very odd, right? It would send a packet towards R1. It would send a packet to R2, to R3 at the bottom left, then R4, then R5, and it would get the reply. And again, it would be very strange. So again, we wouldn't want to do this in real life. I'm just trying to demonstrate an interesting situation here. Okay, all right, let's start exploring what happens if. So as we were looking at R1, we know that R1 has a bunch of things happening here in terms of that 200.200.200 address. It has a directly connected interface on that, but I also showed you earlier that we had a static route, and we know we've got RIP running and OSPF and EIGRP. So the first thing I'm going to do, I'm going to start breaking the network here. So conf t, I'm going to go shut down this loopback interface. Let's just have a think about this. What should happen? What should I see in the routing table, knowing that this router has a static route, EIGRP, RIP, OSPF, and obviously that directly. So any thoughts on, Hank, what do you think? If I shut this interface down, what should we see here?
Ooh, All right. So my expectation here, and I haven't seen the answer key, you can trust me on that one. My expectation is once the static route goes away, not the static route, once the interface goes away, right? It's going to say I don't have a directly connected interface anymore.
Yep.
So that 0 admin distance disappears, and it'll start looking for the next best option, which I believe you said there's a static route.
Let's have a
and
look.
So it should fall back to a static route.
Yeah, I'll just stretch this out a little bit here. There we go. Yeah, so Hank's right, but look, there's something still rather peculiar happening as well. So we've got, I did a shutdown on the loopback interface. What did it do? As Hank was saying, it added the static route inside the routing table because it has an admin distance of 1, right? It was like the next best thing that was available.
Yeah.
But remember what Hank was saying earlier about that /24 versus a /32? My static route is a /24. What's going on here, Hank? How come I'm learning now this?
So the router learned a bunch of different routes from all of the routing protocols. It learned them from RIP, it learned them from OSPF,
Yep.
It learned them from EIGRP. And so each one of those routing protocols maintains their own database of potential routes to use. And so the router starts picking from those potential routes which ones might be valid to go in the routing table. Well, even though it has EIGRP would be preferred over OSPF, the EIGRP route was a /24, right?
Yep.
So the /24 is overridden by the static route that Patrick has configured on the router. So that doesn't show up.
Yep.
OSPF, by that weird nature of the loopback interfaces coming in as a /32, OSPF has a valid interface to come through. It actually has, it gets put into the routing table that's there. And I don't know if you want to scroll back up, we had a /32 route before we shut the interface down because of that local route that would have shown up. Yeah, right here. So we can see we also had a local route in the routing table because routers will always put a local route for every IP address configured on the router, which is why we didn't see the /32 OSPF route before. And so it's really interesting. And this lab that Patrick put together, I really like because it lets us kind of explore step by step what happens in these corner cases. Because while we started out by saying you wouldn't typically do this type of a configuration in your network, there are use cases where you may have multiple routing protocols running.
Oh, for sure.
If you merge two companies together, you're trying to connect two different offices, you may have to have more than one routing protocol. And the same IP address in different parts, that's a little unusual, but sometimes we actually have that for a concept called Anycast. Where we have a service that we want to have available everywhere at the same IP address. So these types of things that are weird do legitimately show up in network designs that are out there. So this is a chance to explore the impacts.
I'll just ask you guys one quick question, then maybe we'll check the Slido poll. Yeah. If I was to ping, again, so if I log into R1 here, which I am, and I go ping 200.200.200.200, I think we're all agreed that it would use, well, which entry would it use if I was to ping that address specifically? Would it use the static entry or the OSPF entry?
And those of you in chat, feel free to put that in
please,
the Q&A so
very
that we
quickly.
can see that. So if Patrick goes to ping 200, 200, 200, right, the full address, which route is going to be used, the static or the OSPF route?
Any thoughts?
Votes for static?
Votes for static, yeah.
Votes for OSPF?
OSPF?
All right.
So I'm glad I've asked this. So towards the end of the session, I think we'll come back to this a little bit more. The thing to keep in mind is the longest prefix match becomes the best choice for the router. So if I ping 200, 200, 200, 200, that's 32 bits of an exact IP address. It's going to look through the routing table to find the best longest match. And guess what the best longest match is? That OSPF entry. If I was to ping something else in that network, 200.200.200.10, the best longest match then would be
our static,
the /24. We'll come back to that. That question I just asked you, you're going to see a lot of those on the CCNA exam. It's a really important topic to come to grips with. We'll come back to it towards the end.
Absolutely. Awesome. All right,
let's have a look at this. Yeah.
Poll. Yeah.
We're going to switch over to the Slido here. So I came up with some funny questions for Slido today. So a router learns the same prefix. So again, I was inspired by the lab we're doing today. It's learned it from OSPF, EIGRP, RIP, another strange sounding protocol called ISIS, which isn't in the CCNA. Service providers use that a lot. And another funny one, external BGP, which is used in the internet. Which route source will the router use to add the prefix to its routing table? Now, the reason I'm asking that question is because you need to know what that list of admin distance values are for quite a few different protocols. You're going to get a question like that on the CCNA exam for sure. I'm quite happy with the results here.
I am as well. Here, I will. I think I can reveal the answer. Maybe.
Show the correct answer. It is, in fact, eBGP. So what happens is we already knew these three, right? We knew OSPF would be 110, EIGRP would be 90, RIP would be 5. ISIS, Hank, do you remember what that one is? Putting you on the spot.
Geez.
Look at this. Anyone ISIS?
I don't remember
admin
ISIS,
distance
actually.
for ISIS? I asked Hank because I wasn't sure. I think it's 115. Maybe someone can Google that and give me a thumbs up if that's the case. It is. All right, great.
Oh.
eBGP, anyone know what that one is? The admin distance, it's a really small number here. Really small number. Not as small as 1, but 20. 20 is the admin distance. In other words, if you're running external BGP, so between, let's say, your enterprise and your service provider, it's going to trust those entries, right? Those learned networks or prefixes the most compared to everything else.
Awesome. All right, well, that's good. I'm going to go ahead and start the next Slido question, which as we'll continue on our routing journey here.
There we go. This one's pretty easy, I think. Okay, so next step here, what I'd like to do is remove the static route. So you see what I'm doing here. I shut down the loopback interface. The next thing is I'm gonna get rid of the static route, and then we're gonna slowly remove the other routing protocols just to see what happens in the routing table. So I'm gonna do no IP route 200.200.200.0 255.255.255.0, and the next hop was that. So that should remove the static route from my routing table. Okay, so what are we thinking? What are we thinking is going to happen in the routing table? I still have OSPF running, EIGRP running, and RIP. All right, I've got those three. Any thoughts? Hank, what do you think? I'm going to put you on the spot again.
Sure. So we've removed the static route. Remember, static route was an admin distance of 1, so it's highly preferred from a routing choice. After that, we would then default back to what the next most preferred one is.
Yes.
So we've got sources for RIP, EIGRP.
Yep.
But strangely, not OSPF because we've got the /32 from there.
We do.
So what we will end up with is EIGRP because that is more preferred than RIP. Oh, and in fact, we actually have multiple routes, it looks like. Oh, no, sorry, they're different routes. I was looking at the wrong one.
So what we have here is I've removed the static entry, and I still have my OSPF, my RIP, and my my EIGRP running. It's selected the OSPF route only in the routing table for now. That's the only one that's being advertised.
Why do we not have another one?
That's a good question.
Is it running it?
I think it's running it. Let me have a look here.
Well, no, it's got D routes coming in.
Yeah, that's running. So it should be receiving all of those.
Ooh, it's always fun when a lab goes in a direction that you don't expect.
Exactly,
live
but
in a
nothing
webinar.
will have changed here. So I think Hank and I were expecting, oh, maybe it hasn't just added it to the routing table. Hang on a second. Did I pull up the routing table too quickly? No, I haven't actually. Okay.
Oh boy.
This is interesting.
No, Patrick.
So my loopback interface is shut down. That's good. I've got my OSPF entry. Let me have a look here on R3 if I'm still advertising the loopback interface.
This just goes to show that it truly is a live presentation.
It is. Yeah, /24. It's advertising the /200 network. I mean, it's definitely advertising it because R2 has it in its routing table.
Look at R1 at the EIGRP database.
Sounds good. Show IP EIGRP data. Oops, need to.
Use
yep.
Spelling.
Come on. No, topology.
Oh, that's right.
I'm not getting it in the topology either. Okay, this is interesting.
Ooh.
Let me pull up my PDF here for a second and see what the PDF has to say.
I feel for Patrick right now. He's getting a cold sweat down his back as the lab is not doing what he expected.
There must be an explanation.
Oh,
so this was the step where we shut down the loopback interface. That made sense. This was the bit where we removed the static route. That made sense.
This is where we look at the answer key.
No,
you're not seeing it there either.
Is it because it's the longest prefix, /32? That's preventing the EIGRP entry from being added to the routing table.
Yeah. It's coming in on that side. So OSPF, because it's longer, it's being picked up.
Yeah.
I think this is one that we're going to have to take off the radar a little
Yeah.
bit, dig into this, and we will come back with our CCNA prep series through the community posts and learning and figure out exactly what went weird here on this one.
Yep, definitely.
I would have expected a /24 to come in from EIGRP.
Me too, definitely, definitely.
Ooh. Even those of us that are up on top instructing and teaching these topics, every time we dive into something unusual, there's something more to learn. So don't feel bad if you don't understand what happened in your network. Sometimes we don't either.
A little surprised, yeah. Because if I go back to R2, you can see that earlier we had 4 entries for each of these, right? Because we had the loopback existing on 4 different routers. I shut down the loopback on R1, so now we're down to 3 entries. So it would still do that load balancing we were talking about.
Yeah.
This is on R2, but R1 definitely is not getting the /24. So I have to have a think about that, but that's all right. It's always exciting when we do a live lab like this. So what I'd like to do next is remove the EIGRP entries from the routing. Let me just pull up the routing table again so we can have a look here. So we know that we've got RIP, EIGRP, and OSPF running. We can see that we've got the 10.2.3, 10.2.4, 10.2.5 networks being learned through EIGRP because of the lowest admin distance. I'm going to go ahead and remove EIGRP. So what should we expect to see now? If I remove EIGRP, so EIGRP is no longer running on R1 or router 1. What's going to happen in the routing table, Hank?
Well, we'll lose all the EIGRP routes, right? Anything that's been learned from EIGRP will be removed because the topology entries aren't there, and that's how the routing table is built. And then I would expect if we have these EIGRP routes for 10.2.3, 2.4, and 2.5, we would learn, if we've learned them from OSPF, we would get them from there. Oh, and sure enough, that time it worked as expected.
As predicted.
I was getting a little worried. Things were going to go really weird.
Yeah, exactly.
Awesome.
We'd have to, like a video game, save and restart the game again or something.
Yeah.
Right. So as Hank was saying, the EIGRP entries are now gone. We have OSPF entries because it was the next most trustworthy source of information. Absolutely. Right? We had 90 for EIGRP. We got rid of that, and I was expecting the OSPF entries to be added.
Fantastic.
Next one, let's take out OSPF, right? Because we have RIP also running. So let's have a look at what happens here. So no router OSPF 100. So I kind of gave it away. What do we think is going to happen now?
OSPF has gone down. We can see that the neighborship is gone.
Yeah.
So we're going to fall back to whatever's left. What is the router left with after EIGRP and OSPF are gone?
Now, this is normal. It's going to take a few seconds here. RIP isn't the fastest to update the routing table, but it should come up at some point. There we go.
There they come.
Here's a trick question. Maybe not a trick question.
No.
How often does RIP send messages? Does anyone remember?
That's a good question. I'm trying to remember. So years ago, when I earned my CCNA, RIP was the routing protocol we had to know, and I would have known the timers back then.
Yeah.
But I don't know. What
anyone remember?
Is it 10 seconds?
30 seconds.
30 seconds.
Every 30 seconds.
That is a long time
right?
to wait.
And don't forget, it's not a triggered update. It's just every 30 seconds, here's my information. Every 30 seconds, here's my information, right? And so it just takes a little bit of time. In this case, it had the information just to add it to the routing table. Yeah. So we've now, but notice what's happened. Because I got rid of OSPF, what happened to the 200, 200, 200 network, though?
Well, it's gone completely, which comes back to the same reason we're not sure. So
yeah, there might be something going on in our CML here.
Yeah, there's something keeping it out of it.
If I show run, I definitely have my RIP running. We've got the loopback interface. I mean, it comes down at this
point, your R2 is not advertising that route to R1 for some reason.
Yeah, exactly. Yep, you're right. And obviously, I'm not going to see it in our R2 because the routing table is still full of OSPF or EIGRP entries.
I think I might know the answer, Patrick.
Okay.
Trying to think through this. All right, let's see how well I can remember back to my old CCIE route switch days. I think a router decides it considers the routes that are in its own routing table when sending routes out, right? So it's going to consider the routes that are there as it goes through.
Yeah,
so when it looks down here, and we don't have it, it's not learning this route for 200, 200, 200 through RIP.
Yeah. Yep.
And so it's not sending that route out in its RIP advertisements to go in. And we didn't have it from EIGRP. Why would we not have had it there? So
yeah, that's a strange one for sure.
Yeah. We're going to dig into this one. I really want to know where those routes are not showing up from.
Exactly. So that was the whole point of this particular lab, just to show you what happens when we have different sources of the same information. How does that get added to the routing table? So Initially, it was because it was a directly connected loopback, so that was why it was in the routing table. We got rid of that. Then there was a static route that was added to the routing table with an admin distance of 1, and got rid of that. And then we got EIGRP entries, we got rid of that. And then we had OSPF entries, and we got rid of that. And finally, we finished with these RIP entries as well. And again, if you sign up for CCNA Prep, you'll get access to the lab guide as well, which basically shows you what we've been talking about, which is when we got rid of EIGRP, we have our OSPF entries. When we get rid of OSPF, we have our RIP entries.
All right. So shall we check in with our Slido
Please,
questions?
yeah.
See. So we are currently asking questions about the default administrative distance for OSPF. It's a topic we've been talking quite a bit about. I think we're going to bring it up.
Yeah.
And look at that. 97% of the audience has gone after 110, which is indeed the correct answer.
Good.
So well done, those of you here, as well as those of you on the stream coming in. Admin distance is one of those topics that will definitely show up on your CCNA exams. You'll get questions just like this potentially, or maybe you'll see an admin distance in a STEM and then have to pick the routing protocol that matches. So being comfortable with those administrative distances is definitely something. And unfortunately, there are a few topics in networking you just have to memorize, and this is one of those, right?
Maybe we can do another one right now before we jump in, because this kind of ties into what I was hoping to do with you. So we've kind of now dealt with admin distance issues and adding prefixes to the routing table. Once the prefixes are in the routing table, the question we need to ask ourselves is, how does the router use that information to make forwarding decisions? And that's this next topic that we want to talk about. So I'll put up the Slido question, but let me just go back to a couple of examples of what we're talking about here, and then we'll come back to this one and have a look to see what's going on. So again, I'm just going back to the PDF here, and I want to use that for this conversation that we're going to have. So and again, hopefully this is as clear as possible. Once the entries for these prefixes are in the routing table has multiple entries. A packet arrives on the router. Router is going to look at the destination IP and try to figure out how to route this packet. So if we had a situation like what you see on the screen here, a routing table with 3 entries, 1 OSPF, 1 RIP, 1 EIGRP, they all seem to be about for the same network, right? 172.16.00, 172.16.00, 172.16. But notice the subnet mask for each one. One is a /12, one is a /18, and one is a /26. And the question I'm asking in the PDF is, what would happen if, let me just grab the little marking tool, I had a packet. No, that's not good. Let's try that again here. This list right there. What would happen if I had a packet that arrived on the router with that destination IP? Which of these 3 entries would it use to forward that packet? What do you think, Hank?
Well, this is where that concept of longest prefix match comes in. And so it's going to figure out which one of these 3 entries has the longest prefix. We can see the prefixes directly in there. We've got /26, /18, and /12. Now this packet 172.16.020 will match all 3 of those routes. It'll match the 12, it'll match the 18, it'll match the 16. But match the 26.
Yeah.
But because 26 is larger than the other 3 options, it will choose that option, the EIGRP route indicated by the D as the routing source. How'd I do?
Spot on. and I think where people get caught out sometimes is when they're looking at that scenario, they start looking at the wrong thing. You know what they're looking at sometimes? They're looking at these, or they're even looking at these. These values, the ones I just highlighted, they're used to allow the router to decide which entries to put in the routing table. What Hank was focusing on was the prefix length to determine which of these would be used to forward that packet out of whichever interface. So in this case, it would be sent to the 3.1 neighbor out of Ethernet 0/2. Does that make sense, right? So you need to, yes, admin distance was important. Metric also was important, because do you remember earlier when we were looking at the scenario here on R2, right? We talked about the fact that it had multiple entries for the same routing protocol because of that metric that was identical. But once we've done, once we're done looking at that, we then need to look at the prefix.
Exactly. And this is another one of those skills that is definitely something that you want to spend some time on. Having taken the CCNA exam fairly recently, I can guarantee you will see a few questions making sure that you can understand that concept of longest prefix match. These are really good questions because it actually allows us to evaluate your skill set in a few different areas. Number one is, do you know the concept of longest prefix match? And number two is, can you navigate and figure out whether an IP address belongs in a particular subnet identified by a route like that? And so we can practice our subnetting skills along with the concept of simple longest prefix match.
So that first example, hopefully you found it pretty easy. I did that on purpose. I wanted a kind of friendly first example. The second one is a little bit more tricky, but it's the same question. Again, we have a packet coming in on the router with a destination IP of 192.168.10.94. And the routing table this time is a little bit more interesting, a little bit more detailed. We have 4 OSPF entries. They appear to be all for the same network, but maybe not the same subnets. And that's the kicker right there. So they're all, the first 24 bits are the same, right? 192, 168, and 10. But then after that, it goes to /24, 27, 28, and 29. So you could expect a question like that for sure on the exam. Hank, what are you thinking here?
Yeah, so this is the chance where we use our subnetting skills as it goes in. And I've been doing subnetting for many years. It's a skill we learn as a CCNA engineer, and it comes and becomes valuable no matter what you're doing in the network space. And so as Patrick brought this one up, I immediately started going back in my head, remembering my knowledge around binary that's there. So, and I started at the bottom, the most longest. So /29. /29 is a very long prefix match, which means there's not a lot of IP addresses that are going to be in there. And I know like 8 is the number I always remember. So I've got, if it's 10.80, which is what the network is, I'm going to have, it's going to go up to about 8 more addresses than that. So it's going to go to like 88.
Yep.
And all right, so I'm looking for 94. It doesn't fit into that. So that won't be the choice.
Yeah.
I then go to /28, the next longest one that's in there. Binary's fun. Binary goes by doubles.
Yeah.
Right. So I go from 8 to 16. And so that'll take me from 80 to 96, 95.
Yeah. Yeah.
And so now I'm at one that looks like it's going to match. And so that would be my choice. I would pick our third route through next hop of 192, 168, 3.1.
What would happen if we took out that route though? Right? What would happen if this neighbor, right, this 3.1 neighbor went down? It would go to, it would use the
next longest
ones. Does that make sense as well? Yeah. It's just looking for a solution, right? It's looking for an entry that matches, but not just a random match. The best, longest match possible is what it's going to use.
Absolutely.
So yeah, for sure you can expect some questions like that.
Yeah. And this again, you're combining together knowledge about how routing protocols work as well as subnetting. So those of you that are studying for your CCNA, maybe some of you here with us in our audience in the Cisco U Theater, take the time, right? Learn those skills. Learn how to convert subnet or binary to dotted decimal. Maybe start to try to memorize a little bit of those patterns that show up with the different prefix lengths that are in there. It will definitely give you an advantage on the CCNA exam.
For sure.
But it also helps whenever you're just doing anything related to IP address planning in your environment.
If we go back to the Slido, we actually had a question kind of related to this. So here we go. According to the command output on the left, hopefully everyone can see that. It's a little small, apologies. How are packets that are bound for the 192.168.2.0 network forwarded? So you can see we have 3 entries, very similar to what I was showing you earlier, an EIGRP entry, a RIP entry, and an OSPF one. This one's pretty easy, hopefully. So I wonder if I'm seeing, so here we go. We got all these answers. So I'm basically asking which of the entries is going to be used to reach the 2.0 network, Hank?
Yeah, well, in this case, all of them are /24s, which makes it a bit easier. And only one of those routes actually matches our destination that we're after.
Yeah.
And that's going to be I think it's the RIP route?
It is the RIP route, exactly. Yeah.
Checking my answer there. So the RIP route is the one that's going to be selected in this case.
Yeah, exactly.
Absolutely.
I can go to the next question, maybe.
Sure, yeah, absolutely.
Here we go. This is not necessarily related to what we've been talking about for the last half hour, but just to kind of step away from all of the intricacies that we've been talking about and ask yourself just fundamentally, what does the router do in a network, right? What are the basic functions of the router itself? So we can leave that one up for sure.
Yep. See that one goes.
See what we get as answer. If anyone else is playing along, feel free to answer that one as well. It's a multiple choice, multiple answer, so you can expect those kinds of questions as well on a CCNA exam. How many of you have taken a certification exam, a Cisco certification exam? A few of you, yes? Not anyone else? Yeah. So you'll have come across all kinds of questions, right? Traditional multiple choice, single answer, multiple choice, multiple answer. Sometimes it's 2 answers. Sometimes it could be 3 answers. Drag and drop. Is a popular one. Obviously, we have now really good simulations as well, depending on the exam.
We're getting some good choices in here, Patrick. I like this. What's interesting about this one here is a router could potentially do any of these functions.
Yes.
And what's important when looking at a question for a CCNA exam is to really diagnose it. So you know that you can only pick 2.
Yep.
And it wants to know the key functions,
yes.
not any function a router can do.
Yeah.
And if we look at this, the ones that are kind of drifted to the top, packet forwarding and path determination, I think those are pretty good choices as the key results. Even though that we could put an ACL, an access control list on an interface to do some filtering, that's not the key function of a router.
Exactly. What device would we typically relate or associate with frame switching? The answer is there, right? Hopefully that's a switch. Yeah. Log collection. Again, yes, we can collect some logs on a router. Typically, we would want to send it to another router, another device, a server of some sort to collect that. So that's very good. Excellent. And next question here.
Awesome. And I think we're coming up on our last question here.
Yep.
All right.
A router learns the 192.168.10.0/24 prefix from multiple OSPF neighbors. So kind of similar to what I was showing you earlier. What does the router use to determine the best OSPF path to reach devices in that network? Is it going to use the admin distance? Is it going to use the cost, the hop count, the diameter, or the weight?
Ooh. This is a good one in here because we've talked about a few of these different pieces, and these are key concepts to know about routing protocols and how they go in. Now, a key aspect of this, as folks are looking at the question, is to recognize that these routes were all learned from the same source.
Yes.
They were learned from OSPF. And so you have to ask yourself, which one of these sources is used at the point once the router has learned the sources and selected them as they go in? Answers are coming in pretty good here.
Yeah. And again, just to remind you, we saw that exactly that exact situation on the R2 router where we had multiple entries learned by the same routing protocol, and so it added them all. And the only reason it added them all is because these values were identical. If one of them had been better, like a lower, it would have just used that entry. But because they were all the same, it was adding them to the routing table. Let's have a look. What are we thinking here?
All right, cost is taking a pretty commanding lead in the choices, which I feel pretty good about based on how our audience is learning here.
And like Hank was saying, the key here in this particular question is the fact that they're all being learned from the same routing protocol. So we're skipping the admin distance. We know that it's 110 for all of them. We then need to look at that value that was next to the slash. All right, this little value over here, this little 11, right, which is the metric, right? The generic term for that would be the metric, but for OSPF, we call that the cost.
And I think that's the key aspect to remember about this question too. So Patrick gave us a few different answers. We have cost, we have hop count, we have weight. Like these are different characteristics that a route might have. Now, individual routing protocols will worry about cost. OSPF worries about cost.
Yep.
RIP worries about hop count.
Yep.
Right. Weight is something that falls into BGP for sure.
Yep.
Right. Goes in on that side. But once those are only relevant terms within the routing protocol. At the routing table level, those pieces, each routing protocol will convert its version of what's important to the generic metric that's there. And so if we look at that routing table from R2 that was over there, we'll see that we've got, where did it go?
There it goes.
We've got metrics that show up as 11, a very small number for OSPF. We have metrics that show up with 400,000 number, very large number for EIGRP. As far as the routing table is concerned, we don't have to compare those numbers at all because they're within the routing protocol.
And we can see the hop count as well.
Yep. So know what your metric determination is for your routing protocols for the ones that show up. And in the CCNA exam, OSPF is the routing protocol we're worried about, and that's based on cost. Cost is calculated by a router based on what? Right? How do we determine the cost?
The speed of the link, the speed of the interface.
The bandwidth of the interface is how the router determines what that cost for that link is. Excellent. Awesome.
That wraps it up.
I think we're in good shape here. So thank you all for joining us here at Cisco Live. thank you all for joining us from home, joining us back for this bonus episode in the CCNA Prep webinar series. As a reminder, CCNA Prep is something that we do ongoing to help folks study and learn about CCNA. So be sure to follow the links that are available as part of this stream. We've got some QR codes for those of you here. We can make sure you can sign up if you're interested in joining future CCNA Prep webinars. As you're studying, check out Cisco U, u.cisco.com, for amazing tutorials that'll help you in your journey. You can go over to the Learning Network from Cisco.com, and you can find links to resources for CCNA, the blueprint, links back to the webinars, the recordings from these sessions. And every CCNA Prep webinar topic that we cover, Patrick and I work together to put together assessment questions that you can use to practice your skills as you're doing your preparation and your final run up to your CCNA exam. All right, with that, I think we're in good shape. Any final thoughts, Patrick?
Shameless plug.
Oh, sure. Go for it.
Well, in a couple of weeks, we'll be back.
Absolutely.
We have another bonus episode. So these last few episodes that we've done, we've called it season 1. We had done 5 up to now. This is episode 6. We're going to do a bonus episode in a couple of weeks. Hank, what's the topic for that one?
Oh, the topic for that one, we're actually going to dive a little bit into automation and programmability, one of my favorite topics. And we're going to look at kind of demystifying what REST means. What are REST APIs? What do we need to know as a CCNA candidate related to that piece? And we talked earlier, one of our first questions was about coding. Does a CCNA candidate need to know how to code and write Python or any of these? Not necessary, but exposure to some of these topics, specifically REST, shows up on the blueprint. And then I think as we're kind of going on this, we have finished season 1. It's been a wonderful time. Patrick and I have had a great time interacting with you all through the live streams and those of you that joined us here in person at Cisco Live Melbourne. We will be back for season 2. Cisco decided to pick us up for another season.
Netflix. No, sorry. Cisco.
And we've been deciding, we're trying to figure out what the theme might be. And in season 2, we're going to dive into IP services. The things that run in the network that help everything else function. So DHCP, DNS, NTP, all of these are topics that as CCNA candidates, you need to understand and be comfortable with. And we're going to explore each and one of those that are on the blueprint in season 2. So keep an eye out, sign up for the CCNA Prep series. You'll get emails once the dates and the specific topic titles are available for season 2. So definitely sign up. Keep an eye on those emails for us to come through.
And I think mid-January. I think we're looking
at mid-January to get started with that season.
And I think I'm going to see Hank in Amsterdam at Cisco Live EMEA. And hopefully, I think we'll be able to do another live stream on site together for one of those episodes as well.
Absolutely. I think our team behind the scenes that helps bring all of these to life, maybe kind of kicking us a little bit for promising stuff before we've worked out all of the situation. But hey, we're live. We're in front of the cameras. We get to say whatever we want.
Exactly.
Right,
Speaking of live, did you want to have a quick look at the Q&A before we
I've been keeping an eye on it.
Anything jump out? Anything that?
Let me take a final look. We've got.
Because we've been getting questions from folks around the world, and curious to see what we're getting here. Let me just go back.
I don't think we tackled this one. So I've got a question from the chat in here. Anjali asked, "Are networking and cybersecurity interconnected? Which topics form the base for CCNA?"
Right.
All right. So you've got some experience on this side. So as we go through, like CCNA and cybersecurity, how do these things fit together?
So the cybersecurity aspect, I think, is critical these days. But at the end of the day, the network has to work. The network has to be able to forward the traffic. The network has to be able to offer the services that your users need. Once that foundation is in place, then we can start looking at what else we need to do to protect our users, protect our data, protect our infrastructure. And that's where the CCNA cyber ops or cybersecurity comes into play. We look at different kinds of threats and attacks. So I think they go hand in hand. Sometimes we hear about an enterprise or a company having a NOC and a SOC. And they kind of point fingers at each other. You know, it's your fault. No, it's your fault. These guys have to work together, right?
Absolutely. And even though we do have cybersecurity associate, right, which focuses in on those types of topics, even at the CCNA, you will see security topics. We talk about concepts like exploits and vulnerabilities and threats and how they factor in. We make sure in the CCNA that you start building those networks that have to work. They definitely have to work, but we want them to work in a secure fashion. And so I think in a future season, we're actually going to dive into those security topics related to the CCNA. So definitely it's something we're going to dive deep into. All right, skimming through our questions here, I think we've done a great job. Our team behind the scenes has done a fantastic job making sure that the questions that came in were answered. So I think
So
we're
who
good
was
to go.
behind the scenes today? Was it Rigo was there helping us out?
We had Rigo and Matt behind the scenes helping
Yeah,
us there, and then we also had Andy running our production
he's like just hiding
studio,
behind the wall
right
here.
behind our wall. So thank you again to
thank
those folks
you.
back there. Yeah, I think we just pounded on the wall. Andy's done a great job here at Cisco Live, making sure all of our Cisco U sessions have gone off without a hitch. And we've got more today. So if you're joined from the CCNA Prep series, but you were unaware that we had all of these sessions going on in Cisco U, by all means, check out the Learning Network. Look for Cisco U over on YouTube, and you can watch all of the rest of the sessions we have streaming here from Cisco Live here in Melbourne in the U Theater. All right, with that, I think we finally are probably done.
I think we're good.
We're going to go ahead and activate a final poll here. Those of you that were watching the CCNA Prep series, please give us feedback. Let us know how we're doing on this side. It's really important for our team so that we can make sure we bring you the best content available, and we can go from there. Awesome. All right.
Thanks, everyone. Thanks for joining. Thanks for those of you that joined us today. Really appreciate having some of you nodding along, smiling at our jokes. Always helpful.